Today's topic is mobile development, in particular, mobile cross-platform development. So we're going to talk about mobile apps. But first question, why would you want to create mobile app, native app? Well, for starters, you want your users to have native look and feel. You don't necessarily can achieve that with mobile web, with just responsive web design. You may need to introduce offline capabilities to your application. You may want to use things like Bluetooth, location services, in general things that are on device, on specific devices. And last but not least, you may want some App Store presence. Okay, so let's explore. What does native look and feel really mean? Who's in here using iOS on a daily basis? Okay, and Android? I use both because I am a mobile developer, so I have a few phones. But yeah, every platform has some specific UX patterns and layouts. For example, on iOS, we are used to gesture-based navigation, while on Android, we have things like back button. Okay? So each platform's user expects slightly different behavior of a native application. We have things such as different checkboxes, different button layouts, and yeah, iOS users are used to iOS layouts, while Android users are used to Android layouts, material design based, we can think. What about on-device capabilities? Let's suppose our application heavily relies on location services. I worked with an app Uber-style-like application, so we need to track user and the driver. We can't achieve constant location updates with mobile web, with progressive web applications. Okay? So if you need to introduce location services, Bluetooth, camera, things like advanced AI models, especially offline, you may want to consider building native application. What else? Offline mode. You know that the time is money, and users are generally impatient. How long do you wait for your web page to load? Well, the research shows that many users, if they expect to have page fully loaded and responsive in 3 seconds or less. So if you rely on just mobile website and your user has unstable connection, you may lose that user. You may lose its user attention. So yeah, offline mode can be achieved with native application. We can use SQL, non-SQL based databases on the device. And why? User opens an app and already some content is present. Okay, so offline. What else? App Store presence. How many ChatGPT clones were there in the app stores before they launch official app? No one really can count. But App Store is a really valuable piece of real estate. So if you're not in the App Store, your mobile application, there's a high chance that, that other companies will come up with similar products. So, and the most valuable real piece of real estate for mobile applications is when the user downloads your app and puts it on his home screen. You can't necessarily achieve that with mobile web. Okay, so we don't want to create just responsive web design. What options do we have? Well, you can wrap your website into web view, make lightweight copy of a browser application, and your application will be just displaying your website. So, okay, so that's possible. And you can have an icon, you can have App Store presence, but it still will be website wrapped into a mobile application. Of course, you can write fully functional native application. And what does native mean in that context? Well, you have to create two applications. One application for iOS devices using Swift and Objective-C, or write Android application with Kotlin and Java. But there is a third way. You can use cross-platform framework, and that's the topic of today's discussion. So let's discover major mobile cross-platform frameworks. Well, I think you already heard about React Native. So, okay, we know React Native is there, but other major player in the cross-platform development world is Flutter, backed by Google. And the third framework I will discuss today is Kotlin Multi-Platform Mobile, and it's quite interesting. We'll get there. And other notable mentions are Cordova Ionic, C#-based frameworks, and stuff like Unity. It is designed for games, but you can actually create an e-commerce application with Unity. It's not reasonable, but it's possible. Okay, React Native. React Native has the promise that you learn once and you can then write anywhere, the same application. So it should be intuitive for front-end developers. They are using JavaScript, TypeScript, the toolchain they already know. But React Native has actually lower performance on the device due to its internals. Because when you are writing React Native mobile application, you're actually writing JavaScript. And this JavaScript then talks to some middle layer, we call it the bridge, and this bridge then talks to the native frameworks of either iOS or Android. So there is this bridge, and we lose precious milliseconds on every interaction. And what is developer experience with React Native? Well, you don't necessarily have to learn new language, but you need to learn slightly new framework. You have the concepts you know from React for web, but mobile is something else. There is nice toolchain with framework called Expo. You can create with that framework actually React Native applications, and there will be faster interactions in the development process. And community for React Native is actually nice, and there are a lot of libraries to achieve common stuff. We have Bluetooth integration, location services, stuff like that. So you can build fully functional app in React Native. Okay, but I told you about Flutter. And Flutter is something else. It is framework backed by Google. And it's an interesting situation because Google has native framework with Kotlin, Java for Android, real native development, and they are also promoting cross-platform framework, Flutter. And Flutter promise is build apps for any screen. So it is slightly different promise than in React Native. React Native says learn once, write anywhere. And with Flutter, it actually makes sense because the framework itself is focused on UI development. They conducted an experiment when, with the first versions of Flutter, when they told the designers, okay, now you need to write some piece of code with Flutter, and supposedly it was easy for designers to write Flutter code. But there are some cons with Flutter, because it uses not so popular language. This language is Dart. And for me, Dart with Flutter was the first time I was using that language. So it's not standard like Java, C#, something else. It was niche language that was introduced to Flutter for some reason. I'm not sure why Google didn't choose any other language for that. And what about performance of Flutter applications? Well, it's actually better, because Flutter incorporates its own engine, both for rendering the stuff on the screen and for its engine. So it's a whole new UI system. You have this C++ engine, and it should run faster. But there is a downside of it all, because with native applications, the size of an app is like 5 to 6 megabytes. And when you create Flutter application, you need to add to the artifact the whole Flutter runtime, and the most simple app size is at least 20 megabytes. So it's not the best solution if your app is targeted for third world countries where mobile internet isn't cheap. Okay, and what about developer experience? Well, as I said before, developers need to learn completely new language that they haven't used before. They used Java, they used Kotlin, they used C#. Now you need to learn Dart. Okay, but new language for experienced developer shouldn't be a problem. And some time ago, tooling for Flutter was crap. But they are working on it, and toolchain for creating Flutter application is getting better and better thanks to community that came from Google, and now we have a lot of open source stuff for Flutter. Okay. And what about Kotlin multi-platform? The promise is different. The first version of Kotlin multi-platform was to enable sharing logic code, not the UI code, but the, I think, backend code for the mobile application logic between Android and iOS. So for Android application, the app would be native. The same app as you would just create with regular Kotlin or Java. But then you can create a library and export it to include in iOS project. Okay, so it is something else. Now they are working on sharing the UI code too. So it may be a better solution for existing apps. If you already have Android and iOS application, you may want to share some code between those apps. And the good starting point would be defining models for server responses or something like that. And the bonus point is if you have backend in Java or in Kotlin, you can share the same code with server applications too. So for Android application, it would be truly native experience. And for iOS, you would include library with some logic, and then you would call iOS specific implementations. And then the UI. The UI is actually in early development stage, this sharing UI. Then you would delegate UI code to Swift UI. This is framework for creating views on iOS. And on Android, with the same code, you would create Android UI. So this should be quite nice, because only half of your mobile development team would need to learn a new language. It's other kind of problem to convince iOS developers to use something else than Swift, their main language for iOS development. But Android developers now can create iOS applications. But the hard truth is that there are still a lot of experimental features, and it's hard to configure properly. So if you have experienced developers in your team, give Kotlin multi-platform a chance. So do we have a winner here between Flutter, React Native, Kotlin multi-platform? And I think there is no winner, because those frameworks have different use cases. With Flutter, you create MVP-type application focused on UI to iterate fast, make beautiful designs, and push your product to the market. With React Native, you can do the same if you already have JavaScript developers. Okay? And with Kotlin multi-platform, you can start incorporating cross-platform capabilities if you already have Android and iOS applications. So you can't always get what you want, but if you try sometimes, you may find just what you need, and I think you may find just what you need with Kotlin multi-platform mobile. And I'm saying this not because I love Kotlin language. So I'm curious, what are your experiences with cross-platform development? And I think we can discuss it during short Q&A session. Thank you.